Hi everyone, and welcome to the Agentic Analytics Summit. I'm thrilled to have you joining us online from around the world. We have people from Prague, Brazil, France, Germany, London, Canada, Boston, Pennsylvania, Malaysia, Ukraine, Switzerland. And welcome everyone. Thank you for joining us. Today we're going to explore how AI agents transform data and analytics. And I'm very excited about the first guest session that gets right to the heart of what agentic analytics can achieve in the real world. So I'm delighted to introduce Tim Handley, who is the Chief Product Officer at Welbee. Tim is not just talking about agentic AI, he has built it at scale. And under his leadership, Welbee has created a secure, multi-tenant agentic analytics platform that serves hundreds of schools and districts. Tim is exactly the kind of session that shows us the future is not coming, it's already here. So please join me in welcoming Tim Handley. Tim, stage is yours.
Great, thank you. It's so great to be here, and thank you for welcoming me into the summit. Just a brief intro, as Michael shared, I'm Tim. I look after both product and tech at Welbee, or Edge Intelligence, and we're a startup, scale-up based out of the UK. We work with schools and trusts and districts to help them make sense of their data and to make data-driven decision-making really easy for them. And the key way we do that is through our Agentic analytics system. As a bit of a background, we've had Agentic analytics to a degree within our platform since last September and have released a significant upgrade to that capability about 2 months ago, partly for help acute for D3. So what I want to do is to take you through kind of our journey in terms of what we have built and also why we built it and some of the key decisions we've made and how we've architected that decision. So we're going to kind of balance a bit of the technical with some of kind of the real world kind of use cases and decisions we've taken and what's happening with our customers with it. Obviously, there's a Q&A and a chat screen. If you've got any questions, I'll try and address them as we go through or at the end if we get some time. But just to set the scene about why we do what we do is that we know that schools, districts, ministries, education suppliers are really drowning in data from siloed school systems. So if you think that traditional BI kind of use case is kind of siloed, you haven't met some school systems where you've got assessment data somewhere, attainment data somewhere else, and data about behaviour in another system. And actually all that data kind of joins together to give a really great view of the school, the students, and the education outcomes that we want. And that means that our users and schools and districts really struggle to identify what's going to have the biggest impact. They want to have a great impact. Schools and school leaders do amazing things. But because they've got this data fragmentation, it can really lead to high stakes failures. Now, I'm in the UK and stats in the UK for education are getting worse and worse, despite the best efforts of the sector. We know that persistent absence, so that's children who's been away from school for more than 10% of the time, is rising or has risen after COVID and is struggling to come down. It's now about 19%. We know the number of children struggling from mental ill health has risen up to around 20%. And we know that together, there's lots of research that says financial consequences of this to a society can actually total over 10 trillion globally annually when we look at things like lost school days and lost attendance. So we have a real kind of purpose to what we do and helping schools kind of address that and join lots of different data sources together. But after we join our data sources together, obviously it's actually how do users access and see that data. So we built Edge Intelligence, which is our secure AI ecosystem, we call it, because everybody likes having ecosystems in tech, that aggregates and analyzes the data together, and it recommends actions. And a key theme you'll probably hear from me throughout today is that data by itself is not really that useful, particularly to our end users. They actually want to know what it means and what they can do about it. And it's informing policy, it's informing school decision makers. We have over 35 million different data points collected to date from different data subjects. We have over half a million students' data in our system across 200 different school systems that we connect together. And we know that by using the system, our users can save over 90% of the time that they tend to spend on data analysis tasks in a sector where the people using the system are not data analysts. We're talking about head teachers, superintendents, and people in the school sector who have not got the data science or data engineering skills to be able to actually make the most of the data they have. But they're certainly not short of data. So just a brief bit about our data architecture, just to give kind of the groundwork in terms of what we built and how other people can build something similar. We have BigQuery as a cloud data warehouse. We have a complete silo model of multi-tenancy. So each of our districts or school groups or individual schools has their own data set to keep everything simple, given the amount of PII and confidential data we deal with. There is then sub-tenant row-level security. So if you think about a district in the States, we have each school within that district has got their own row-level security kind of access controls as well. We use Airflow and Astro for orchestration, DB2 transformation layer, all kind of the standard tech stack that everybody uses. We have Cube as our universal semantic layer, which for us, for our AI use case particularly, is really key because it means that our front-end kind of BI, which is embeddable powered, can talk to the same data in the same way as our AI and the chatbot interfaces that we build for our users. We found that when we look at our data and data usage, that we have about 85% of our use now happens via our agentic system versus our traditional charts and dashboarding. So whilst we still do provide charts and dashboards for people to have fun with if they want to, actually about 85% of our use cases now happens and our users now happen via our agentic system. But I think it's important we talk about agentic AI to kind of look at actually why we are using agentic AI in the first place. Why aren't we just using procedural logic? Why aren't we using dashboarding? Why aren't we using a myriad of other kind of strategies that are out there? Because I think particularly with AI and talking to lots of colleagues, we tend to find that people jump to AI just because it's AI sometimes without actually thinking about actually the use case. We chosen to go for agentic AI because we know that simple text to SQL would not cut it with the limitation of the type of data we have and the data security that we need to apply. We know that linear flows of AI prompts, kind of chaining prompts together, were not responsive enough to our users who may one day be asking about behavior, who the next day might want to know about their HR policy and how to deal with a staff member, and who the next day might want to know about attendance and how it's varying. We also know, and again, a key theme is that tabular data that we can store in a data warehouse, etc., is only part of the picture. And we need to be able to combine that tabular data, so data we can get from school systems, with their unstructured data that we get from their policies, their documentation, etc. We also know that not every LLM is created equal and equally as good for each task. So within our agentic ecosystem, we have 6 different LLMs that work together, a mixture of Gemini and Claude models, largely with some specialized models within there to help address different elements of the task. And we also know that data questions anywhere, but particularly in our sector in education, can be really complex and have many interplays together. So whether we're looking at the relationship between attendance and behavior, for example, and the links between those, or achievement and attendance behavior on stakeholder feedback, those relationships are quite complex, and it requires more than one agent, more than one LLM prompt, for want of a better word, or stream of prompts to be able to manage that, which is why we've built our agentic ecosystem. Now, everybody loves an architecture diagram, and here is our heavily simplified architecture diagram. And if you want to connect with me on LinkedIn, I can share more about what sits within some of these boxes. But we decided when we're architecting our agentic architecture, there's too many A's in that sentence, to go for a supervisor or supervisors approach. So we have our kind of main supervisor that sits at the top, which interacts with our user. We have developed that supervisor and prompt engineered that supervisor to think like a school leader, because ultimately that's who our users are, but to combine that school leader expertise with what a data analyst may think. So that means a user can ask a question, which we'll show you later, something like, how is behavior? Our user doesn't want to know the answer of, oh, behavior is looking good, thank you very much, and here's the points from today. What they actually want for a question like that is, how is behavior? Is there any subgroups that behavior is looking different for? Does it look like my behavior policy that you've got access to is being applied, and all that information? But they may just send a simple prompt. So our lead supervisor does a lot of the heavy lifting when it comes to working out what the user actually needs from their question they're asking, to effectively re-prompt that, and then to call through our tool nodes a series of different subsystems that work to do different things. So in our case, our subsystems each have their own supervisor, hence the supervisors, and can each work autonomously and then feed back into the greater subsystem, greater agentic architecture we've got. So for example, we have a subsystem that looks at survey responses because we have lots of survey data, and the way we process that's very different to, say, behavior or attendance data. We have subsystems that look at our unstructured data, so a semantic RAG that we built over school documents and policies. And then we have the kind of bits we'll all hear about today, which is that kind of semantic layer subsystem, which interacts largely with the help of CubeD3 and some bits around that to actually take a user's question. If the the supervisor agent has decided that a data question from their tabular data would be useful to answer, it will route it through to the semantic subsystem, which will prompt it out to D3. D3 will go and find the dimensional measures that are relevant within our semantic layer, and then it will go from there. We also then have other subsystems built from that. So we have a representation subsystem that will decide, actually, has the user's question going to benefit from having a representation or chart, and if so, it will go and generate that and show that via embeddable. And then the key part of what underpins everything we do is our action engine, which makes sure we take that answers and the kind of the raw data and the insights analysis from that, turn it into something that is digestible to the user, but also is followed with next steps and actions. So we know in our context, and same in any other context we look at analytics, that actually our end users want to know the data, but they also would like to know what they can do about it too. And that's what this action engine is designed to do. And then we have a kind of a prompt that just summarizes everything together to make sure that we're presenting in an intelligible way to the user. So what have we learned when we're building this? So we built this, and I say this has been live in the system in this form for the past kind of 2 months, in a site simplified form for the past year. We learned that good supervisor prompts are really key. So we can talk about supervisor systems and agentic AI all the time, but actually prompting that supervisor and making sure the supervisor can work efficiently has been really key. And that's where we've invested a lot of our kind of prompt engineering time, is in making sure our supervisors and our sub-supervisors in our subsystems really kind of work well together. We kind of follow a kind of a set of making sure that we tell the supervisor what it's doing and what its role is and what the user's role is. We make sure it knows what its sub-agents or tools can do. We make sure we know how we want it to synthesize its outputs back together so the agents can talk well together. And we also importantly want to tell it when to fail gracefully. So when it doesn't know the user's answers to the question, to go back to the user to get them to clarify. When it can't find the right type of data, to go and clarify that or escalate and say, I don't know, rather than starting to make up data or make up queries that might not actually answer the user's question. We also learned very quickly the importance of the semantic layer when it comes to agentic analytics, that if we were trying to do this with text to SQL, effectively what you'd find yourself building in code is a semantic layer with definitions and joins and pre-joins made. And obviously the semantic layer in Cube really helps with that. And it's really key. We have tried, when we were trying to architect the new system, to see how much semantic layer we could put in or take out, and actually we got the very best output with a semantic layer in the middle, and really drawing and driving our agentic analytics in the middle and that data access. It's also really key for us, giving our shadow multi-tenancy with that level security combination, so we can have the access controlled largely through Cube, and make sure that people are getting access to only the data they can see with the right level of normalization and pseudonymization within that. We also learned that our data is only part of the picture, and that agentic analytics has to be tailored to our users' context, and that's where our unstructured data and that part of our ecosystem really comes in, which is our kind of semantic RAG kind of style approach. And also that analyzed data, as I say, by itself isn't really what users want. They want to know what to do with it, what the actions are, and they want those actions to be tailored to their context. So we, for example, will have part of Action Engine is some web search, but it is a tailored web search to high quality education resources. So we're not effectively telling school leaders to run their school by AI. We also learned a lot about UX for agents, and we tried lots of different things, as I'm sure lots of people have listened to this, about actually how do we get our experience to be the best for users. When we did lots of user kind of testing and feedback, actually they found that they loved the familiarity of a chatbot, and we all know what a chatbot looks like. So when I share our platform very briefly in a minute, it looks like a chatbot, like you'd expect to see from ChatGPT, Gemini, and Claude, because actually there is now really a expected appearance for agentic systems and chatbots, and people are used to interacting with systems that are structured in a certain way. So much we tried different approaches. Actually, the things that got the best user feedback was a familiar chatbot experience. Our users also shared is that they want and actually deserve to know how the response has been arrived at. So the thinking that, in Lucy's term, that agentic systems do, and showing how that answer has been arrived at and what's going on behind the scenes, particularly when it's taking a while for a response to come, is really key for our user experience. We knew that, and we found out fairly quickly that if we show the thinking and what's going on, our users will wait for 5 to 10 times longer than they will do if it's just like thinking bubbles. So you'll see in a second that we have lots of clear narrative from the AI about what it is doing and why, so that it kind of helps with that users, and then they will willing to wait and know, and particularly as they know it's access their data securely. And a key thing we have built throughout it is that our AI can deliver really great insights without seeing that raw level student data, because it does everything in aggregate through the semantic layer. And that linked to that we with the UX needs to take every opportunity you can to reinforce kind of the key security and efficacy messages. So we've added information to the kind of thinking information that AI gives out about securely accessing your data, accessing the data without seeing raw children's data, and the kind of key messages we know our users want to see and hear. Cool. So I'm going to very quickly attempt what people should never do with AI, which is a mini live demo just to show you what it looks like in practice. So I'm just going to switch over to sharing my screen briefly. Super. So as I say, we aren't looking at anything dramatic with our UX. It is a chatbot, but users can ask questions like looking at one of the questions our users asked literally just before came in this call, which was how is behaving in their school. Now this is our fake data, but you'll see straight away it's starting to tell the user, okay, what is it planned? So it's going to analyze survey responses related to perceptions. It knows in this data there's just been a survey closed. It's also going to analyze the school data system to understand them as the metrics related to behavior, to provide a comprehensive view. So it gives us its plan straight away. The user can see, do they like it or not, effectively. But rather than waiting to the user to approve that plan, our users said to us they actually want the AI to just get on with it, and they can always stop it if they don't like what it's saying it's doing. So you can see it's kind of thinking through and doing the analysis, and we find we tend to have a response time between 30 seconds and a minute. So I'm not going to make you wait. I'm going to stick to one we did earlier. And you can see here that when we ask questions similar like this, you get information that combines both this empirical data that we got from the school's data system, and this is our fake data, so every child has had behavior incidents, which is not normally the case in schools, and then combines that, finds the patterns and insights and any correlations there, and then finds it from any surveys it's done, researches what to do next, and kind of gives an overview of what could happen next based on that stakeholder feedback, based on that data, and kind of joins it together and gets support services out there. And it can go from things like that to people wanting to know about attendance, for example. So this conversation that one of our test users had is about, okay, how has attendance varied between year group or grade? Found its patterns, gives recommendations, and then they can dig down and say, okay, well, actually in year 8, is there a big difference with those special educational needs and not? And it will break it down even further for them. One thing we have found really useful is to make sure that we trace everything. So we use Langsmith as our kind of tracer of choice, but this is an example of how a conversation looks when it's traced for us. And that means that if any elements of these AI prompts or any elements of our tool calling, etc., kind of go slightly away, or the answer isn't quite as we would expect for a user, that we can trace easily. We can say, okay, actually what's happened when it's gone out to the Cube ecosystem here, which is the analyze school data, sorry. What's happened when it's gone out to the AI. So I think definitely when we're building agentic systems, that having tracing and whatever tool that you use, whether it's Datadog or Langsmith, etc., really helps. And just to finish before maybe we take any questions or spaces we've got, I think we're nearly there anyway, just to show what our users say. So our users are very very positive about what we do, and this is probably our favourite quote, that we know that it's making a real difference to our school users particularly, and that tasks that used to take them hours to do and maybe they could do it ineffectively between different systems now take leaders minutes. So thank you very much for having me.
Thank you so much for the presentation, Tim. And I want to say that the time savings you demonstrated for customers shows what's possible with properly architectured agentic analytics. And also special thanks for showing the live demo. So I think our viewers were really excited to see how it works behind the scenes. So we have some time for the questions, and let's take a question from Steve. Steve is asking, how do you join the unstructured data with the structured data and handle all the missing data when you convert everything to a rectangular format?
Yes, so we join those for different elements of our subsystem. So the query will go out both if the supervisor deems it relevant to the user's question, both to the structured data via cube, but also go out to our unstructured data system, which is a combination of RAG, everybody does, but with some more semantic chunking, etc., going on within there to keep the context between the different documents people upload. And then the supervisor is then trained to synthesize that data together, and the part of the node that sits to the left of the supervisor is that kind of summarization synthesis layer that will synthesize those two data sources together, and then can go back as well. So it can look at our unstructured data, realize there might be some unstructured data that might benefit from some structured data about, and go back through the system before it goes back out to the user. So I think it's about making sure that agentic have access to both and treat both equally, and can combine and synthesize those to the end user, whilst letting the end user know where the information's come from. That's how we manage it.
Great. Thank you so much, Tim. We really appreciated having you here, and thank you for your insights.
No worries. Thank you so much.